My name is Stephen Kasica and I'll be presenting TableScraps. This is joint work with Charles Berret and Tamara Munzner at the University of British Columbia. We perform a technical observation study of data wrangling from computational notebooks and scripts written by journalists in the wild. And from this qualitative data, we develop two taxonomies, one of actions taken by journalists and a second of process observations recorded by the research team. We observed many things, the most salient of which was the extent to which journalists use multiple tables in their wrangling environments. This prompted us to reconceptualize wrangling as a multi-table process through our new framework. In this presentation, I'll begin by discussing journalism as a microcosm and then describe our study, our process, details of our two taxonomies, and our multi-table framework. Then I'll conclude with two critical incidents that demonstrate these contributions in action. This is a compelling group through which to study wrangling. Journalists are often cast as a non-technical user group, but a subset of data-literate reporters and editors use many of the tools and techniques common in data science to produce so-called data journalism, and much of their work is the result of extensive data wrangling. Even small articles can require lots of wrangling, and these articles often contain a quote-unquote nerd box, a sidebar or snippet in an article that provides a methodological description and a link to further data reporting materials, such as this piece by BuzzFeed News. The analysis code and raw data for this article is stored on GitHub, and we found hundreds of repos like this one publicly available on the platform. Journalists are encouraged to perform this service for editorial transparency so that the public can scrutinize their analysis and also for colleagues to reproduce their work. Our study looks at what these repos can tell us about how journalists wrangle data. We perform a qualitative study on 50 such repos authored by more than 30 journalists. We find that journalists perform many common wrangling tasks, but the extent to which journalists use multiple tables extends far beyond what we normally consider as data wrangling. Data wrangling has been studied among many groups, including enterprise data analysts, data scientists, but not data journalists, so our study provides a never-before-seen look into the processes of this user group with implications that we anticipate will extend far beyond data journalism. Our process is characterized by the indirect observation of users' technical artifacts, or a technical observation study. So to understand the wrangling practices of these data-literate journalists with programming skills, we conduct this technical observation study in two subphases. First, we systematically select relevant repos from public code repositories, such as GitHub and Observable HQ. Then we perform rounds of iterative qualitative coding, developing open codes from observational data, and categorizing these open codes through axial coding. Along the way, we produce sketches of how data flows from table to table in the wrangling environment, and this gave us a high-level overview of the wrangling process. Out of this, we produce our initial set of taxonomies, our first contribution. To determine which practices align with or diverge from existing characterizations, we search relevant literature to discover gaps in other work and also to harmonize and align our codes with common terminology. We update our taxonomies accordingly. Existing process theories of data wrangling don't adequately capture the expressive ways journalists use multiple tables to wrangle their data. So to recharacterize wrangling to match these observed practices, we reflect on our own work in the context of other work on wrangling multiple tables, thus synthesizing a multi-table framework, our final contribution. Our first contribution is the set of two taxonomies of data wrangling in computational journalism. These taxonomies are cross-cutting, meaning they offer two complementary perspectives on the same phenomena. The actions taxonomy captures wrangling actions taken by journalists, while the process taxonomy records observations of their wrangling process as interpreted by the research team. These taxonomies are descriptive and extensive. While there are only 7 codes at the highest level of each taxonomy, there are 165 total open and axial codes across both. The further one drills down into each taxonomy, the more specific the code. For example, merge captures the highest level action of combining data sets. And within merge, we make the distinction between union, which combines observations similar to a union operation in SQL, and supplement, which combines variables, which is analogous to a join operation in SQL. Within supplement, we make the further distinction between outer joins, in which observations are retained in only one dataset, and full joins, where observations are retained in both datasets. Within process, we record pain points, where journalists appear to be facing wrangling issues. we noticed many issues arising after the merger of two datasets. For example, data was often lost after an outer join, which we coded in our process taxonomy as a lossy join. Our second and final contribution is our multi-table framework for data wrangling. A key finding from our technical observation study was that journalists use many tables while wrangling data, and this was evident from the complex relationship between table objects depicted in our data flow sketches, where each node represents a table object and each arrow represents a modification to that object. The complexity of journalist workflows varied greatly. Some were relatively simple linear processes that would still be challenging to implement in many interactive wrangling applications. More complex processes utilize dozens of input sources in a bifurcating process with multiple output files. And the most complex would be daunting to perform in any interactive system. And this prompted us to reconsider how we might characterize wrangling to better match these observed practices, and to address the most complicated workflows, such as this one involving 30 tables from the Washington Post. We approached defining a design space by thinking of wrangling operations as transformation functions defined by two dimensions. The first is the type of object, either tables, rows, or columns, and the second dimension is the cardinality of the function's input and output, either 0, 1, or many objects. The result is a concise and actionable framework for reasoning about wrangling operations, and it covers many familiar ones. For example, filtering can be thought of in our framework as a transformation function that deletes rows. Entity resolution, or the task of reconciling multiple names for the same thing, can be thought of as a one-to-one column transformation. Joins and unions in SQL fit under the combined tables category, but our framework can also speculate about actions not well supported. While there are many invocations of combining tables, the inverse operation, separating tables, is not widely supported. However, we observe journalists performing this frequently. We demonstrate these contributions in action through two critical incidents from our set of 50 coded journalist repos. Our first example is a multi-table success story. In this article, LA Times journalists investigate patterns of water usage after California lifted drought restrictions in 2016. And this article contains two common examples of process codes. First, it contains the kind of analysis that revolves around comparing different groups, in this case, water districts. And second, it uses publicly available open government data, which journalists downloaded from a state website. During the wrangling process, journalists encountered a data set much like this one, that contains water supplier, which roughly corresponds to geographic area, the date, the amount of water used in billions of gallons, and the amount of water used specifically in 2013. While variables in this dataset mostly correspond to table columns, the year variable is actually contained in two columns. The date column contains the month and the year for specific amounts. For example, in August 2015, East Bay used around 6 billion gallons. But values for 2013 are in a separate column. However, they still correspond to the month variable in the date column. So the goal here is to wrangle this data into a partially tidy format, where the year variable is only in the date column. To be truly tidy, however, the date column would have to be separated into month and year columns. And this is extremely difficult, if not impossible, to do with only one table. But you can fix this with multiple tables, as these journalists did, using what we called in our process taxonomy as a divide and conquer strategy, where journalists separate one table into many, fix the constituent tables, and then merge them all back together again. But this process is still extremely tedious, even with modern programming libraries such as Pandas and Python. To tackle this challenge, journalists begin by separating this table into three, one for each year, and duplicating 2015 to stand in for 2013. Second, journalists remove unnecessary columns. They retain the 2013 amounts column only in one table. Third, journalists perform two separate one-to-one transformations with columns. They rename columns, trivially a one-to-one transformation, essentially the identity function. And second, they replace 2015 with 2013, since the months are correct. Finally, journalists combine the constituent tables together again, and this produces the end result. Our second and final critical incident is a cautionary tale, illustrating one of the pitfalls of wrangling in a multi-table environment. Using public data from the U.S. State Department, this article by BuzzFeed explores U.S. refugee resettlement data between 2005 and 2015. After aggregating the data by state, the issue that prevents analysis here is that comparisons of raw numbers are biased towards the most populous states. So the wrangling goal here is largely statistical, and journalists address this by bringing in a separate dataset of state population estimates in order to supplement the refugee arrival dataset and calculate a normalized rate of refugee arrival. But these datasets are only partially congruent, unbeknown to the journalists at the time. The refugee table is missing data on Wyoming, since the state has not resettled any refugees during this time period. And when it comes time to combine these two datasets through an outer join, Wyoming is silently dropped, introducing an error. And we code this in our process taxonomy as a pain point, specifically a lossy join, when data is lost as the result of a merge. The news organization was forced to issue a correction shortly after publishing, demonstrating that common issues in data wrangling have real editorial consequences for journalists. In conclusion, our study has two contributions. 2 taxonomies, one for actions and one for processes, developed from a qualitative study of journalists' Git repos. And our second contribution is a multi-table framework for data wrangling that addresses major pain points unaddressed in previous work and is both actionable and concise. Please see our paper for further details. Thank you.